Hello students, welcome to the physics class of class 9. First chapter is motion. Introduction. An object change its position with respect to time is called motion. That means an object moves from one place to another is called motion. There are different types of motion. An object may move in a straight line, other may move in a circular path, some may rotate and a few other may vibrate. There may be a situation involving combination of these. In our daily life, we all are familiar with different types of motions like this. Straight line motion means a car moving in a straight path. Circular motion, an athlete moving in a circular track. Some may rotation. Rotation means our ceiling fan rotates. Vibration means to and fro motion. And we also familiar with the motion having combination of this also. Describing motion. We describe the location of an object by specifying a reference point. For example, we say that a school is 2 km north of the railway station. We have specified the position of the school with respect to the railway station. In this example, the railway station is the reference point. Therefore, to describe the position of the object, we need to specify a reference point called the origin. In this above example, our railway station is the origin here. Motion along a straight line. We have drawn a horizontal line along which we have plotted the distance from the origin point O. We consider the motion along a straight line with O as the origin. For example, in first phase, an object moves from O to A through C and B. And in the second phase, it moves from A to the point B. So the total distance travelled equal to 60 plus 25 equal to 85 km. It is the magnitude of the path length covered. The numerical value of a physical quantity is called the magnitude. Here we can see, here is the distance 5, 10, 15, 20 are in kilometers. So the object first moved from the point O to A, then it comes back to the point B. So the path length means here from here to A point 60 km, then 60 km to this point 25 km. So 60 plus 25 equal to 85 km is the distance travelled. It is also the path length here. Here distance travelled is a new physical quantity. Now the displacement for the total motion is 35 km from O to B direction. Here displacement is another new physical quantity which describe the shortest distance between the initial point and the final point. Here the definition is written. So we see that the displacement is the shortest distance between initial and final point. That is the straight line distance. Here we see in the diagram from O to A and then back to B. In this whole journey, O is the initial point and B is the final point. So the distance between O and B is 35 km. So this is the shortest distance, that means the straight line distance. So this value is the magnitude of distance and its direction is from point O to B direction. Next topic, scalar quantity. The physical quantities which have only magnitude are called scalar quantity. For example, mass, time, distance traveled, speed, etc. Vector quantity. The physical quantities have both magnitude and direction are called vector quantity. For example, force, weight, displacement, velocity, acceleration, etc. So the main difference between scalar quantity and vector quantity is that scalar quantity only have magnitude but vector quantity have both magnitude and direction. Next topic, difference between displacement and distance traveled. First point, distance traveled is the total path length covered, whereas displacement is the shortest distance between initial point and final point. Distance traveled is a scalar quantity, whereas displacement is a vector quantity. Third point, distance traveled cannot be zero for a moving object. Whereas if the initial and the final point is same, then the displacement will be 0 for a moving object. Next is a mathematical questions. Suppose an object moves through a semicircular path of radius 10 meter. Calculate its distance traveled and displacement from the point A to B. Here we see the semicircle. This is the center and its radius is 10 meter. Here radius is 10 meter. First, distance traveled equal to the path length covered equal to the perimeter of the semicircle equal to pi r. We know the value of the constant pi is equal to 3.14 and r is 10 meter. So 3.14 into 10 meter equal to 31.4 meter is the distance traveled. Now displacement equal to the straight line distance AB equal to 2 into r. R we know 10 meter equal to 2 into 10 meter equal to 20 meter is the displacement. Next topic. Uniform motion. An object moves equal distance in equal interval of time. Next topic. Uniform motion. An object moves equal distance in equal interval of time. Then the motion of the object is called uniform motion. Non-uniform motion. An object moves unequal distance in equal interval of time is called non-uniform motion. For example, in the table we see that the time is given in the first column. Distance traveled by an object A is given in the second column and the distance traveled by object B is given in the third column. We see here equal interval of time means 9:30 am. Distance traveled by object A is 10 meter. Distance traveled by object B is 12 meters. After a certain time 9:45 am. Distance traveled by object A is 20 meter and the distance traveled by object B is 19 meter. At 10 am we see that the distance traveled by object A is 30 meter and the distance traveled by object B is 23 meter. At 10:15 am we see that the distance traveled by object A is 40 meter and the distance traveled by object B is 35 meter. So for the motion of these two object A and B, we see that the distance traveled by object A is equal in equal interval of time. So the motion of the object A is uniform motion. Clearly we see that the motion of object B is non-uniform as it moves unequal distance in equal interval of time.